Welcome you all. Today I am Monika Satankar presenting here lecture on the topic of size reduction in solid foods. So the size reduction is the process where the big particle size reduce into the smaller one. So it is a very important during operation after the post harvest of food. So here we are covering the following points in this lecture. So first one is the introduction, principles of size reduction, what are the different forces used in the size reduction, the energy requirement while the grinding, the size reduction equipment and the application of size reduction in food industry. So the size reduction is also known as the combination, pulverization and elimination. So here the size reduction means the bigger particle that are converting into the smaller one by using the different forces, and the forces may be the compression forces, impact forces or the shearing and cutting forces. So the reduction may be involving one or the combination of these forces for the size reduction. So what are the different benefits of size reduction? So after size reduction, the surface area of the particle increases. So while the surface area increasing, the rate of heat transfer, mass transfer and the extraction rate also increases. And it also facilitating the mixing uniformly the product while the mixing operation, and also the facilitating the heat exchange, chemical and the biological reaction during the operations. So the mainly size reduction classified on the basis of the type of product, like the solid product and the liquid product. In the solid product, the final resultant products in the form of graded product, spices, powders, flours, food nectars, powders, starches, and some smooth paste. But in case of liquid, by applying the emulsification and homogenization process, the product reduced in the particle size in the form of like essential oils, butters and ice cream. So here as our topic topic on the size reduction of solid food, so we are focusing mainly on the size reduction in case of solid food. What are the different forces used by the grinding? So here the mainly forces: compression force, impact force, attrition or pressing and cutting force are using by the operation of grinding or milling. So the here we are discussing the equipment that are using the forces by the operations, like the pressing roll. In pressing roll, the main force used for the size reduction is compression. In case of hammer mill, the hammers used for the impact force for the size reduction. In case of disc or attrition means shearing and pressing forces are using for the size reduction in the form of fine particles. Or in case of rotary knife cutter, the main force is the cutting action by the scissor. What is the mechanism behind the size reduction? Here we are seeing the graph between the stress and strain. So when the force or stress is applied on the material, it results in strain development or the change in the dimension of the particle. So here we can see the big line of this graph divided it into two parts. One is the weak material and other is the strong material. Okay, so here the hard and soft material. So E is showing the elastic point of the material, B is the breaking point of the material, and Y is the end point of the material. For the reduction of particle size, the stress required the greater than the elastic limit of the material to break that particular material. So here the line 1 is showing the hard strong break material, brittle material. In the second line it is showing the hard strong and ductile material. weak material, and the line 5 is showing soft weak material. Initially the stress is applied that develop the strain, result in the fracture in the line of the weakness that release the heat. So the while grinding process, the main component is the energy requirement. So the grinding process is very energy intensive process. So for the calculation of the energy requirement during the grinding, different laws are using to determine the energy requirement according to the particle size, reduction of the size of the particle like coarse size, fine size or medium size particle. So after applying the stress, the dimension is changed. Change in the dl in the particle of typical size, that simple power function of the L. So here the energy requirement in case of the size reduction can be determined by three different laws, that are Hicks law, Dittinger's law and Bond's law. The Hicks law states that the energy required for the size reduction is directly proportional to the change in the dimension. It means is equal to K antilog xn divided by x2. Here the x1 is showing the initial particle size of the food, and x2 is showing the size, reduced size particle size after the grinding. The Hicks law mainly using for the size reduction in case of the coarse grinding. Dittinger's law can be defined for the energy requirement in case of the fine grinding, where the energy requirement is directly proportional to the new surface area of the product. So here is the equation that is showing the energy requirement, as the earlier discussed. X2 and x1 is the dimension of the size reduced after the grinding and the initial size of the product. Bond's law states that the energy requirement for the size reduction is inversely proportional to the square root of the size of the product. This is the equation that is showing the size reduction in case of Bond's law. How to calculate the energy requirement? Here EI is the work index, which is showing the energy required to reduce the unit mass of the material from an infinite particle size to the size such that 80% of the resultant material passes through a 100 micrometer sieve. There are different size reduction equipment using in food industry. So first one is a crusher. Crushers are using for the coarse and fine grinding. It involves jaw crusher, gyratory crusher and pressing roll. If we are talking about grinders, so it is using for the intermediate and fine grinding that involve hammer mills, attrition mill, rolling compression mill or the ball mill. If we are talking about the ultra fine grinder, it involves hammer mill with internal classification, food energy mill and aggregated. If we are talking about the cutting machine, so it is like different cutters, knife cutters, dicer and sliders. So first one is crusher. Crusher is not most commonly using in case of food industry. It is simply reducing the particle size in a form of lump. Okay, so in here we can see that in case of jaw crusher, two jaw, one is stationary and other is movable. The movable jaw is attached with eccentric unit, which power the movable jaw, where the feed is entered between the jaw, where the movable jaw is kept at 20 to 30 degree, where it move and reduce the particle like in case of wheat to produce the flour. So in hammer mill, the component of hammer mill is the hammer is attached into the rotor which continuously rotate, and it is assembled inside the assembly where the feed is entered from the top of the hammer mill, and due to the high speed, approximately 1500 to 4000 RPM rotate the hammers, which reduce the particle size, where the different type of springs are attached at the bottom of the assembly, which particularly used for the fine particle or the required particle size. The main force applied for the size reduction is the impact force that reduce the particle size. It is mostly used for the hard and abrasive material, and in food industry it is extensively used for the grinding spices, sugar, dry fruits and dry vegetables. Attrition mill is also known as plate mill. Plate mill, where two plates are rotated, where the one plate is stationary and other is movable. The feed is entered at the middle of the plate, where it goes outside of the plate. Due to the shearing and pressing action between the plate, the size is reduced and discharged from the outer side of the plate. Tumbling or ball mill. Tumbling or ball mill is a type of mill where the horizontal or conical cylinder continuously rotate, which involve ball or rod, which are responsible for the size reduction in case of ball mill, where the half of the mill is filled with the ball and it is continuously rotate. So due to the impact and gravity force of the ball from the sail of the mill, the size reduction occurs. So in this, the very important term is critical speed. So critical speed occurs when the centrifugal force arises inside the mill, where the ball of the mill stick on the ball, and that not release that result in the size reduction. So it is important to keep operational speed below the critical speed for the size reduction in case of ball mill. Okay, this is the diagram of the ball mill. Here we have already discussed, this is the combination of impact and selling force bring about a very effective size reduction. This is also how it actually works. The rotating cylinder, first is the balls, it is large balls, then medium balls, then it is small balls. After rotation, the size is reduced and the particles discharged from another side. Cutting machines. The cutting machines mainly using the slicing and flaking equipment, dicing equipment, threading equipment and pulping equipment. Slicing means the slices are cut by using centrifugal or slice balls by using different cutters or blades. Dicing, it means it is mainly used for the fruits and vegetable, and it can be cut in shape of a strip by rotating blades. And threading, it is commonly used as a modified form of hammer mill, in which the knives are used instead of the hammer to reduce the cutting action. A second type of